myself Dr. T. Sudarshan Ramparma. Today we are going to see about the congestion control and avoidance. So congestion control. Once congestion happens, TCP will control the congestion. TCP representative increases the loads imposed on the network in an effort to find the point at which congestion occurs, and then it backs off from this point. Congestion avoidance to predict when the congestion is about to happen, and then to reduce the rate at which host sends data just before packets start being discarded, but it is not yet widely used. Three methods will be DCP bit, read, and source based congestion control. DCP bit. The first mechanism was developed for use of the digital network architecture, a connectionless network with a connection oriented transport protocol. This mechanism could therefore also be applied to TCP and IP. The idea here is to more even split the responsibility for congestion control between routers and the end nodes. Each router monitors the load, and it is explicitly and explicitly notifies the end nodes when congestion about to occur. This notification is implemented by setting a binary congestion bit in the packet that follows through the router, hence the name is DCP bit. The destination host then copies this congestion bit into the acknowledgement and it's sent back to the source. Finally, the source adjusts its sending rate so as to avoid congestion. As single congestion bit is added to the packet header, a router sets this bit in a packet if its average queue length is greater than or equal to 1 at the time of the packet arrival. This average queue length is measured over the time interval that spans the least busy and idle cycle plus the current busy cycle. Using a sequence length, one is trigger for setting the congestion bit is a trade-off between significant queuing and increased idle time. Congestion avoidance. The value 50% was chosen as the threshold based on analysis that should be correspond to peak of the power curve. The increase of 1 decreases 0.875 rules was selected because adaptive increase in multiple decreasing makes mechanism is stable. Next congestion avoidance mechanism is random early detection. It is similar to this bit schemes is that each router is programmed to monitor its own queue length, and when it's detected that congestion is imminent to notify the source to adjust the congestion window. Invented by Sally Floyd in the year of 1990s, differs from the bit. The first is that rather than explicitly sending a congestion notification messages to the source, RED are most commonly implemented such that implicitly notify the source of congestion by dropping one of its packets. Source is therefore effectively notified by subsequent timeout or duplicate acknowledgement. RED is designed to be used to congestion with TCP, which currently detects congestion by means of timeouts. As the early part of the RED suggests that gateway drops the packet earlier than it would have to, so as to notify the source that it should decreases its congestion window sooner than it would normally have. In other words, the router drops a few packets before it is expected by its buffer space completely, so as to cause the source to slow down, with the hope that this will mean it does not have to drop lots of packets later. The second premise of RED and bit is how RED decides when they drop a packet, what packet it decides to drop. To understand the basic idea, consider a simple FIFO queue. Rather than wait for the queue to become completely full and then the force drop each arriving packet, we could decide drop each arriving packet with some drop probability, whether the queue length exceeds some drop level. This idea is called early random drop. The RED algorithm defines the details of how to monitor a queue length and when they drop packets. This is a queue length of the random early detection packets. Source based congestion avoidance. The general idea is this technique is to watch for some sign from the network that some routers queue building up and that congestion will happen soon nothing is done. For example, the source might notice that the packet queue built up in the network router. There is a measurable increase in the RTT for each successive packet it sends. One particular algorithm explicitly observation follows. The congestion window normally increases as TCP, but every 2 round-trip delays in the algorithm check if the current RTT is greater than the average of the minimum and maximum RTTs. Source-based congestion avoidance, we follow the window adjustment one of every 2 round-trip delays. Current window minus positive, the source decreases the window size by 1/8. If the result is negative or 0, the source increases the window by 1 maximum packet size. Thank you.